Let's start our journey into Java programming by exploring one of its most fundamental concepts, variables. In Java, a variable acts as a container that holds data values during the execution of a program. Think of it as a labeled box in your computer's memory where you can store information like numbers or text. Variables can be local, meaning they're only accessible within a specific method, or they can be static, which means they belong to the class itself and are shared across all instances. For example, when you write int data equals 50, you're creating an integer variable named data and assigning it the value 50. Understanding how and where to declare variables is crucial, as it affects how your program stores and accesses information. As we move forward, you'll see how variables interact with other elements in Java, setting the stage for more complex programming structures. Now that we know what variables are, let's talk about the types of data they can hold and how classes organize them. Java supports primitive data types like int, float, double, char, and boolean, each designed for specific kinds of information. For instance, int is used for whole numbers while double handles decimals. Beyond primitives, Java also allows for non-primitive data types such as classes and arrays, which can store more complex data. Classes are blueprints for creating objects, grouping related variables and methods together. Imagine a class as a template for a real-world object, like a person with attributes such as name and age. By defining classes, you can create multiple objects with shared structure but different data. This organization is at the heart of object-oriented programming, making your code more modular and reusable. The solid grasp of variables and classes. Let's see how objects come to life in Java. An object is an instance of a class created using the new keyword. When you create an object, Java uses a special method called a constructor to initialize its data. Constructors have the same name as the class and set up the initial state of the object. For example, you might have a person class with a constructor that sets the person's name and age. Structures can be overloaded, meaning you can have multiple versions with different parameters, allowing flexibility in object creation. There's also a copy constructor, which creates a new object by copying the data from another object. Understanding how to use constructors effectively helps you manage object initialization and ensures your objects start with valid data. This is a key step in building robust Java applications. Programming isn't just about storing data, it's also about making decisions and repeating actions. Java provides several control flow statements to help you manage the logic of your programs. The if else statement lets your code choose between different paths based on conditions. For more complex choices, the switch statement can handle multiple possible values. Loops like for, while, and do while allow you to repeat actions until a condition is met. You can use break to exit a loop early or continue to skip to the next iteration. These tools are essential for tasks like processing lists, handling user input, or performing calculations repeatedly. Mastering control flow gives you the power to write dynamic and responsive programs that can handle a wide range of scenarios. Finally, let's tie everything together with the core principles of object-oriented programming, or OOP in Java. OOP is built on four main pillars: abstraction, encapsulation, inheritance, and polymorphism. Abstraction means hiding complex details and showing only the necessary features. Encapsulation bundles data and methods together, protecting the internal state of objects. Inheritance allows one class to inherit properties and methods from another, promoting code reuse. Polymorphism lets you use a single interface to represent different underlying forms, making your code more flexible and scalable. For example, you can have an abstract class animal with a method makeSound, and different subclasses like dog or cat can provide their own implementation. Mastering these concepts will help you design clean, efficient, and maintainable Java programs.